Hi, everyone. Hi. So, okay, I don't know, follow me on Twitter or on Mastodon or wherever you want to follow me. Anyway, let's talk a little bit a second about me, a few more interesting details. You are probably using a lot of my software. If you're not, it's probably installed on your computer. So I am one of those people with a few billions on download of NPM. So if you want, there will be a basket going around, and you can put a cent for each download of a software that you did for me, and you can just put 1 cent each, and I can start collecting some money. No, I'm totally joking. Anyway, I am also board member of the OpenJS Foundation and a bunch of other things. And recently I founded this company called Platformatic with a friend of mine. I'll probably talk a little bit about it later on. But today, right now, we're going to talk about something else. Choosing a new technology. Should you choose A or should you choose B? Okay, should you use React or should you use jQuery? Look, jQuery is an amazing technology, okay? It powers most of the websites on the web. It has to be great, okay? Is the right technology that you would... React is this little thing that's just used by hipsters, right? So should you use React or should you use jQuery, okay? You know, this is a question. This is a phenomenal question that you might want to ask yourself when picking a new technology. Should you write your backend in C, or should you write it in JavaScript, or Java, or .NET, or whatever you want to use? How do you choose a new technology? How do you choose a technology how do you choose something, okay? So let's talk a little bit about the Pareto Principle. This is called Pareto Principle, or the 80-20 rule. Okay, where is it? Okay. The 80-20 rule, or the Pareto Principle is kind of the same thing. It was codified initially by a mathematician, it's an Italian mathematician, back in the few years ago, and he said that it's been popularized so far in this way. What does he say? Well, that 80% of the outcomes result from 20% of the causes for any given event, and of course these are just fake numbers, okay? Like this is just empirical data. So the core concept of this principle is if you observe a natural phenomenon or an economic phenomenon, you can only a few factors depends on the actual result, okay, that you want to measure. And, how does it matter for software, really? And why does it matter for choosing a technology? Okay. Well, you probably have experienced this, that, you were working on a project, and the vast majority of the feature takes absolutely no time to build, okay? Your team goes like a breeze through them, okay? Then you end up with the latest, hardest feature to ship, and what happens? Then you get stuck, and things do not ship anymore. And the management gets very upset with you that you can't ship your stuff. So why is that? Well, just to consider it, something very, very interesting of the 80-20 rule, and the fact that certain features are actually very hard to implement. Do you remember when the first iPhone came out? How many of you had one of those? Yeah, okay, do you remember that it didn't have copy and paste? Literally, the first iPhone could not copy something and paste it somewhere else. You had to type it again, okay? Turns out that copy and paste is actually a very hard thing to implement across in an operating system. If you have tried it, it's fun, okay? And they didn't ship it, okay? So you could, get away from the 80-20 rule, just not shipping features. Okay, that's our trick to ship product on time. You just don't ship the hard stuff. Okay, that's how you do it. Okay, you just don't ship the hard stuff, and that's what the minimum viable product is all about. Okay, just don't ship the hard stuff. From time to time, though, the hard stuff is the things that people would want from your product, and you actually need to ship them. And if somebody tried to ship a phone today without copy and paste, I don't think they will get very far. So it's also a matter of time, and if you can just do what Apple did at the time. Unfortunately, the life we live on today is about efficiency. The demand for software is ever growing, and we want to ship faster, faster, and faster, and faster, and faster. Can we do it? Can we get it done yesterday? This is a question of, can we ship something yesterday? Could you? Okay, could you go back in time and code something? And yay! Reality is that whenever somebody picks a technology, they pick them because they can use it to ship faster. Not because it's more secure, not because it's more ergonomic, not because it's better, not because it makes coffee, but because it enables people to ship software faster. And this is essentially what drives business and this field in the last few years. So what technology would you choose? Okay, to be honest, I would choose technology that's more fun to develop with. Okay, so I'm trying to dance where people were making a photo. Okay, it's if you want Pareto tells us that 20% of the features are 80% of the effort. 80% of the features relate to 20% of the effort, which typically goes at the start of the project. Okay, when we need to ship something up, we can ship feature very quickly. We start with a good template, and we can just get things done in no time. And then we get stuck on the complex feature when the complex feature, and we lose a lot of steam, and we have a lot of effort. Now, the problem with that is, like, when we pick a technology, okay, we need to pick a technology that is really good at the start of the project, and a technology that also enable maximum flexibility for the complex features. And this is why it's great, and these kind of technologies are, this is where, if we want to reduce the effort, we must cater for those two things. Okay, both the repetitive task, like CRUD and all the basic things, and stuff that is actually very specific, and we want maximum flexibility. So, okay, and this is a framework, okay? Like, we want to reduce time to ship software. We want to make sure that we can do the repetitive task and whatever, the easy tasks, and something that's also super flexible, that we can implement very custom things on top, like a piano player, just to reconnect to the previous talk, which is amazing, and you should all watch if you are watching the recording. So, what is all about? Okay, I'm a backend engineer. I work on Node. So, if we can reduce the effort and time, and for both repetitive and complex stuff, we can do the way dance if you are here, and it's going way, because we can ship stuff in less time. But look, if instead we only focus on the easy parts, then on the easy application, things will get worse, okay, and nobody will be very happy about it. And I worked for a few times at a few companies where technology were picked by the nicest tutorials that was available. Okay, how many of you are nodding? Okay, and then everything went horribly bad. Okay, like horribly. But the tutorial is amazing. Why it's so hard to ship this feature? Everybody could do it. Anyway, so I'm a backend engineer, so let's talk about a topic that I care, object-relational mapping. I'm sorry, how many of you have used a database, one or ever? Yeah, I've seen a few people. Okay, great, perfect. I just wanted to check because there is a few good UX people in the room, so I didn't want to scare you too much. Okay, you have a database, and if you have a database, you can map those database to JavaScript or to any language using something called an ORM that will create you some code. Now, what ORM does, it promises you, this is what it says on the tin, spaghetti, very neat code base. Look at how neat is this code base. It's neat, right? That's the code base that you will get. That's the promise. Okay, that's in the pack. Okay? That's what it promised. Okay? Let's talk a little bit more about the promise. So this is essentially a model, okay? And you have, for example, like a quote that extends the model class. Look, this extends, okay? This is, the problem starts here. Extends model, okay? I don't want to open that discussion, okay? You can watch the previous talk, 2 talks before, and read a few books to say, well, this is probably not a great idea. But the other part here is that this kind of concept, it's really bad for a few reasons. First, it has too many responsibilities. It stores data. It knows how to save stuff, delete stuff. And you can also do a like, which is business logic on the topic. Yeah, how many of you have coded something like this or worked at something that looked like this thing? Okay. So this is not a good representation, okay? Because one of the problems here is that what happens when you hit save? This is an async operation, okay? What happens with the state of your if you mutate your object after you have called the save method and you are awaiting that function? What happens to that data that is being held in that model? You can know. It's complete. It's a Schrodinger's box. The cat might be dead. So you just don't know. Okay. Also, it goes into the topic of the model view controller pattern, which has been popularized in a long time for web apps, and you have probably seen it in all the times in your work. You probably will not have seen what happens at scale with this. So what happens at scale, let's say that you start working, it's you and your friend, you're doing a startup, and you just start building your nice MVC application and using any of those technologies, and you add a table and you have a model, and then you add another with rates to the first one, and then you add a team, so now you are 20 people, oops, and everybody keep adding models, okay? Soon, put it a couple of years, if you're very successful, you end up with 2,000 models and 2,000 tables in your database, all relating to each other. Do you think anybody can understand how all of that works anymore? Okay, it's very, very hard to understand any of this. Okay, why is the problem? Well, because you have, when you add a new feature, you can only put in 3 places in the model view controller pattern. Either it's a model, okay, I understand this maps data, is a controller, oh, this receives my calls from my HTTP server, or it's a view. Oh, wait a second, it's not even 3, because a view, right now we're mostly doing SPAs, single page applications, so we are not even going to have a view, we're just doing JSON. So, oops, it's just 2. Okay, so in reality is models and controllers, and either a model or it's a controller, and that's our 2 boxes in which we put new features. And it's not a great way to scale if you only can put something into 2 boxes. So this does not really work well in the growth and scale of your project. Also, you see ORM removes some of the easy parts, okay? But the reality is that when you need to add complex features and more stuff, as we said, they typically stand in the way. They're not very easy to extend. You need to stand down and just do SQL and do a lot of these crazy things. Reality is that ORMs have actually shipped, have created so much spaghetti code in your applications since the 90s. Okay, it's the delivery of it, okay? And I love my carbonara, so please. We can talk about carbonara later. Okay, yeah, so ORMs help only with the repetitive tasks. Okay, so what should we do instead? We said we want a technology that we want to do both things, right? What should we do instead? Okay, let's talk a little bit about some stuff I did a few years back. If the MVC module pattern, MVC pattern model view controller does not really work, what can we use instead? Well, you could use what is called the modular monolith as a solution. Okay, this actually scales. You can find a lot of documentation on what is the modular monolith, and you can be implementing in all sorts of languages and patterns. But the key concept here is that even though you're building a monolith, means that I'm just deploying everything in one single step, what happens is that I'm dividing my application into independent modules that talks to each other using known messages and function calls and stuff. They are separated, they have their separate tables and databases and so on. Maybe even the same database, but they're not interact with each other, so that they can be owned and maintained by a team. Okay, this goes back into the topic of teams. Why it's important? Because you want your team to owning a piece of code. Okay, this is the fundamental part. Building software is a social activity. It's not you just don't code it on your own. This type of topic is very important, but you can even go one step further on this, and you can just say that you can do a microservices from there. Because if you have divided your application in nice, good modules of features, okay, you could actually take some of those features and extract them and put them into their own microservice or another service, or how you want to call them. There is a lot of information about these topics, by the way. If you are interested, you can go to you can Google it up and talk about there is also something new, which is, I think, macro microservice or something like that pattern published around. So, okay, going back to the pragmatic choice is to choose a framework that enables to build us the most complex features. So we want to do both. Okay. So and so these. Oh, that's fun. Okay. It has been bugging me all day. Okay, I didn't want to update before the presentation, but it actually showed up. Okay, so. In fact, the best line of code is the one that I don't have to type. Okay, this is the best one. It's great. And in fact, why should I even bother to type code if I can just ask ChatGPT to code it for me, right? That's probably not going to end very well. Anyway, have you ever tried Copilot? You will probably see what I mean. Oh, this is totally dead now. Okay, fun. Did it go? Okay, it's going back. Okay, so so we were here. I don't have to type. So when I'm a backend engineer, as I said, developed backend for most of my careers. So what I want from a backend is a few list of very interesting features. Okay. I want something that can run on my computer. I don't know, many of you are freaks like me in that sense, but I really want something that I can run on my computer and it all works on my computer. I don't want something that only runs on the cloud, because if it does not run on my computer, how can I know if it does even work? Okay. I also want something that I can extend also via code and also native data. I want to use SQL. Like, I love SQL, so I'm probably one of those nerds. But SQL is a great language. But you can, whatever database you want to use the native driver. Don't use those meta languages and over meta languages on top. I want something that does some basic authorization for me. Like, I don't know, many of you have implemented authorization systems. Very hard to implement right. I don't know. Like, don't try, or try and understand the pain. And then, GraphQL. How many of you love GraphQL? Good. How many of you like REST? So in this room, there are more people that prefer GraphQL than REST. I did the same survey online, and 74% of people that responded to on Twitter from my poll told me that they prefer REST. So very interesting data points. I love federation. This is a thing from GraphQL. I want something that I can deploy on my own servers. I don't care. And something that works across multiple databases, because why not? Okay, I want to use MySQL, Postgres, or something. You can just use Postgres, to be honest, if you want to be cool. Yeah, I want to do all of this, and I just want it done because I don't want to code it. How can I? So, okay. Yeah, I want to have the cake and eat it too, as they say it in England. And so, by the way, a lot of chocolate in the cake. So, okay. So this goes back to, I founded a company, right? So that goes back to what we do. We try to solve this problem. Nice, ring, okay. And we try to solve this problem and give you something that provides both something very good for the start of a project, but also maximum flexibility in long term and for implementing most of the complex features. You can find us at platformatic.dev. The website is very skinny at the moment, but that's what it is. So okay, let's do a little bit of a demo. And by the way, this is all live, so if the demo gods are with me, it all works. If the demo gods are not with me, it's not going to work. So the travel gods were not with me the last weekend, so hopefully the demo gods will be with me today. So what we can start with is this code. This is an NPM module, create Platformatic, and can enable you to create something good. We can create a Platformatic DB adapter or just a Platformatic service. We'll just create DB service a little bit more advanced. So we want to use this folder. Yeah, we want a migration. We want a plugin. Okay, this is a nice question. Do you want to use TypeScript? Yeah, I'm not. And I'm not running npm install on a conference Wi-Fi, so bear with me, okay? Oh, and do you want to create a GitHub action to deploy application? Yes, we are going to use that later. Okay, so let's move to a different branch though. Web. Okay, so here we have just run our things. What we can do, the plt command is the command for Platformatic. So we can just run plt db migrations apply. And it's going to run my migration. By the way, it's complaining that I need to run some dependencies, and it actually generated some types for me automatically. So.
Could you refresh the screen because we cannot see the last line?
Sorry, I don't understand the. Sorry.
Ya han puesto preguntitas.
Oh. Okay, just let me try something different. If I do this, okay, fun. Okay, is it good now? Okay, perfect. Okay, it has even generated some types because I'm not probably using types, but you probably would. So I am of that camp of people. So, okay, so, now we can start this and go Platformatic. Platformatic in PLT is the same. DB start, and it's complaining about a deprecation warning, but let's not talk a little bit too much. So, welcome to Platformatic DB. What does this do? This is local, by the way. And this is loading from the network. And as I said, network is a web conference Wi-Fi. Let's talk a little bit about local. The document. Let's show this one while it loads. So it provides you a full OpenAPI definition that you can generate automatically from our database. So, and it has created us the default migration, okay, in here. Let's look at it. The default migration has created us a movies table with an ID and title, and that has been mapped to movies endpoint, but also this is, okay. Okay, so it has mapped it to let's try to refresh it. Okay. To our GraphQL endpoint, so we can actually save this and say, for example, Harry Potter, and Harry Potter, and we can get the ID and title. It's using SQLite locally, and now, as you see, we stored it in our mutation, and we can count the movies, for example, or get all the movies, and there is quite a few complex, nice things that you can do here if you want, and you can get the ID and title. This is all nice and expected. I can also do REST. So here, this is our automatic OpenAPI definition, and we can, if we want, we can just run this, and as you can see, I get some curl, and I get my response, which is Harry Potter by default. Cool. What is this all about? Well, this seems pretty good, right? Let's do a commit now. So we have seen this work locally. So let's do that and web. So we are pushing this up. And this is a GitHub repo, by the way. We have been, I am opening up a pull request on my GitHub repo. And it's running. It has created a GitHub action, right? You remember that it created a GitHub action. Yeah, OK. Oh, the GitHub action is actually running. What is this doing? It's churning. NPM install takes a little bit of time. I'm sorry. I can't claim any responsibility for it, but I can claim that some of the downloads are big. And it's probably the heaviest object in the universe at this point in time, the node modules folder. Okay, it always takes a lot of time. That's super bad. But look, it done. Oh, it's deploying it. Oh, updating code archive to the cloud. Where is it deploying to? Takes a little bit of time. Oh, it's done. You have a URL here, different smelly genial celery. And if we go back to our PR, it's taking a little bit of second, it says that your application was successfully deployed. And yay, here we go. It is the website that we talked about before. It's the same thing as we have locally, by the way. But different database, though, because if we get our query, I can get all the movies and ID and title. And it's, this is, yeah, it deployed the database. Cool. I did add the database. Haha, fun. Now I need to update that gitignore file. I can even save some new movie here. Let's go. Which movie do you like? Which movie do you like? Die Hard. Okay. And yeah, I need to do this. Wrong. Cool. Okay. And now it's title. Here we go. And then we go the ID of Die Hard. And yeah, input. Yeah, that's why. Here we go. Okay, let's add Die Hard. And here we go. And now we can get new movies, all the movies here. And this is, by the way, you can try it online if you can copy that long name. And movies, ID, and title. And as you can see, this is being stored and published. It's all done. Now, you said this is very good for creating backends very quickly, right? Did I tell you that we need to do some complex features too? So, OK, so what we can do here is we have this concept of a plugins. Now, it also have auto-completion, but it needs the dependencies on NPM. So I'm not going to add them. What you could add them, for example, is new routes. So let's call it web. It's a new get endpoint, and hello, web. OK, so now I can git st, git add. By the way, I can just curl this new endpoint immediately. So I don't even restart my local machine, but web. it automatically picked it up. So I just need to restart it automatically. That does all the things. But if I go into my endpoint now, I haven't deployed it yet. So I can just do way web. Of course, this is not working. OK, good. So now I can just git commit and update and push. And it's now doing the same thing it was doing before. And here we go. Where is it? OK. Now you see the action is running again. And it's going to deploy the stuff and get it updated, hopefully, if everything works correctly. And it should. But, you know, this is new. So it's always a leap of faith, right? We can keep talking about NPM that is low. Anyway, the gist, let me show you some other stuff in here while we are waiting. Something that you could do with this, for example, is you can even do a subscription. So you could get a subscription when a movie is saved, and you can get the ID and title. And if, is trusted. Did a mistake here. It's not working. OK. It crashed. Fun. Bugs. Bugs are fun. OK. So here I can run my subscription. And now I can, for example, do a mutation and save Star Wars. And in my subscription, it received the data live. So it's also good technology for getting live updates to your front and stuff. OK, did this run? Oh, this did run. So we have successfully deployed it again. So let's refresh our REST definitions. And in our REST definition, now, where is it? OK. You can see that there is a way. Oh, this is local. OK. So I need to go to my GraphQL one. OK, here we go. So here I can just go to web. And hello, web. Thank you. OK, so what do we do? You know, the development process here is actually very simple. You can just define your schema for your database. And you know, even this, if you have an already existing database, it works. So you don't need to create your model definition or anything. Yeah, I'm good. I'm mostly done. You told me you could. I could be shorter. And I can go on and show a lot of features. And then just write some custom code. So I see that I have a little bit more time. So let's go back to the code. I'm going to show you something even more fun. OK, so we are back here. This is a very small screen in which I'm coding. So hopefully it's very small screen where I'm coding. So OK, so git status. So what we can do is, OK, let's do something. Echo git ignore db SQLite. I don't know what I'm doing. db SQLite git ignore. OK, so at least I'm removing this file. OK, cool. And OK, I'm just actually fixing it because I can't stand stuff being not fixed. OK, fix up. Cool. OK, this is fixed. Now, next one, let's do a new migration. So let's say that we want to create some new stuff. OK, let's start a new table. So plt mydb migrations generate gets a migration for us, and I can just here ask Copilot what he thinks we should create. So create quotes table. And again, this is Copilot tell us to do this, which is wrong, by the way. But it's, look, is what it is. Let's do that. And we have created that field, which we probably don't need now. So, OK, so let's run this new migration, OK? PLT DB migration apply. And, well, while we are running this, let's run npmi, so it's just doing its thing. Now, here, what we can do, let's run this again locally. And PLT DB start. And in here, this is our thing. Now we can refresh this. And in our query, now you see we also add the quotes. How does this relationship is mapped? So let's say that we want to store, let's say that we store Star Wars, okay? And we want to also store Harry Potter. I zapped the databases, so okay, we have Harry Potter. And now we can save a quote from Harry Potter. So we can do our mutation and do save quote and input. And we want the, yeah, I didn't do something. I need to do something more, okay? Because I didn't add a reference. So let's add another migration. Migrations generate. And OK, I am adding another one for alter table. Do you know the syntax to? Oh, no. Alter table quotes, add column, movie ID. Let's see if it picks it up automatically. Integer reference movies ID. OK, Copilot is amazing for live demos, by the way. Like you can make it. OK, so PLT DB migrate. Migration apply, running it again, OK. So now here I can refresh it. So I can say that I can refresh this up. Movie. Oh, I did it in the undo? So much fun. OK. Haha, you see, I did it wrong. OK. So I did it in the undo. No, I did it in the do. I didn't do anywhere. OK. Here we go. OK. So, OK. Git diff. OK. So let's do PLT DB migrations -t002. And migration apply T002. OK. And then apply it again. So, OK, now it should be there. OK. And I can save that I want to store move ID. OK, now it's there. And I want the text from Harry Potter. So I solemnly swear I am up to no good. OK, and now I want the ID and title, ID and text of my quote. And, quotes author. So this has been said by Harry Potter. OK, I'd saved this. Now I can get my movies, but I can also ask them for their quotes. And I want the ID and title. And, sorry, ID is not the title, it's the text. And I can get all of this automatically for it. I can even go around and deploy this stuff. Git add. And this will get deployed and fixed by the GitHub action out there. Cool. I think I'm done. 5 minutes. I think I'm probably pretty good. So while this is being done, how is this architecture? How does this world work? So there is this daemon that I'm running called Platformatic DB that provides both OpenAPI and GraphQL. It allows you to map, it reads the schema from a database and publish it of both OpenAPI and GraphQL. but you can also create it to your code. It's all built on this framework that I wrote a few years back. It's called Fastify. How many of you use Express? Okay. How many of you have heard of Fastify before? Yay. A few of you. Yeah, you should probably use that instead, but I'm not going to tell you to try to convince you too much. Yeah, that's kind of it. The cloud is now in private beta, and you can claim an invite at platformatic.dev, and I'm done. Thank you.